Welcome to Coach Eichner's Math. Today we'll be talking about polygons, specifically the interior and exterior angles of a polygon. First thing we want to look at is how many sides our polygon has. We know that polygons are labeled by their sides, so if I look at the first picture, it has 3 sides, that's a triangle. Second picture has 4 sides, that would be a quadrilateral. Third picture has 5 sides, we know that is a pentagon, and this next picture has 6. We know that is a hexagon. Down here at the bottom we have n-gon. What if we don't know the number of sides? Say there were, for example, 42 sides. We'd say it is a 42-gon. So for their number of sides we're going to put the letter n. This bottom column is going to help us create a pattern or a formula so that we know what we're looking at. If we're looking at the number of triangles in this next column that can be created by our polygon off of one vertice, drawing diagonals, there is no way to draw a diagonal inside a triangle, so there would be exactly one triangle inside of that triangle. If I want to pick a vertice, it doesn't matter which one, so I'll pick this bottom one, and I want to draw a diagonal. There is only one diagonal that I am able to draw, creating 2 triangles in a quadrilateral. If I pick a vertice in my pentagon in a very similar fashion, I'm able to draw multiple diagonals from the same vertice, which allows me to create 3 triangles. Likewise, in a hexagon, I am able to do the same thing, except, as you may have noticed by now, there's a pattern that's developing. As I draw my individual diagonals, I am now able to create 4 distinct triangles from that one vertice, drawing diagonals. This is important because it will help us when we're trying to determine total interior angles in just a moment. But right now we want to look and see, is there a pattern? When I had 3 sides, there was 1 triangle. 4 sides, I had 2. 5, I had 3. 6, I had 4. So when I have n number of sides, what you want to know is that we have n minus 2 number of triangles inside of that shape. That's important as we turn to the next part here, where we look at our total interior angles. Well, we know we have 1 triangle, and a triangle we know always has 180 degrees interior. Well, if we know the triangle has 180 degrees interior, on my second triangle, or on my second figure here, the quadrilateral, I have 180 degrees, but there are now 2 triangles, which makes 360 degrees total. On the third shape, there are 3 triangles, which is going to put me up to 540 degrees total. Likewise, on the hexagon, there's now 4 triangles, which allows me to say that I have 720 degrees total. If you notice a pattern, my 2's go together, these 3's go together, 4's go together, because this number right here is just how many triangles is my shape created. So, for a total interior, the sum of the interior angles of any polygon, say we have an n-gon there, we would say 180 degrees times the number of triangles, which is always going to be n minus 2. So let's take the next step. Now let's look at the total interior and see if we can use the total interior and discover each interior angle. So I know a triangle has 3 sides. It also has 3 vertices. If it is a regular polygon, which is important because we know a regular polygon has congruent angles and congruent sides, If it is a regular polygon, that 180 has to be split into 3 vertices. 180 divided by 3 gives me 60 degrees. Looking at the next figure, we have 360 total degrees, and I have 4 vertices, so I would say 360 divided by 4 would give me 90 degrees. Likewise, 540 divided by the 5 vertices, I would say that each angle has 108 degrees. 720 total interior degrees divided by the 6 vertices, because it's a regular polygon, and we find that each angle of a regular hexagon would be 120 degrees. So what would I say in general? The top number was always just the total interior, which we already know is 180, n minus 2, and then we divided by the number of vertices, and the number of vertices is equal to the number of sides, n. So we'll say 180 n minus 2 divided by n. So now we have a simple formula to find the total interior and to find each interior angle. Now, looking back the other direction, we said that each interior angle is 60 degrees. So if I write my 60 degrees in there for all 3 angles on a triangle, we know that we've got each interior angle. So what about the exterior angles? If I extend my line out, now I'm looking at my exterior angle. We know that we have a linear pair. These 2 angles must be supplementary. So 180 minus 60, which is 1 interior angle, is going to give me the exterior angle, which in this case is 120 degrees. Now, there's 120 degrees, well, we have 3 external angles. So how many total degrees would we have on a triangle? 120 times 3 would give me 360 degrees. This makes sense because a polygon is a closed figure, and a closed figure must always get back to the starting point. Go full circle, mind you, which is always going to be 360 degrees. Let's see if it works the same for the next one. If we have a regular quadrilateral, each angle is 90 degrees. So if I plug in 90 degrees up in the corner and I extend out, I have a supplemental pair, 180 minus 90 gives me 90 degrees. Well, in a quadrilateral, there are going to be 4 total exterior angles. So 90 times 4 would give me 360 degrees. So as a general rule, we know that there is always going to be 360 degrees, no matter what, for total exterior angles. So the sum of all exterior angles will always be 360 degrees. We can continue on the same track and plug in our interior angle and subtract to find our exterior angle, or the other option is we can take the total, because we know it isn't going to change, and divide by the number of angles we have. So 360 divided by 5 is another way to find how many degrees each exterior angle is, which in this case is 72 degrees. Again, 360 divided by 6 would tell me each exterior angle is going to end up being 60 degrees. So for an n-gon, there are 2 different ways we can do this. We can use each interior angle and subtract from 100, or simpler, we can say that it is always going to be 360 divided by the number of sides of our polygon. This has been Coach Eichner's Math. I hope you liked our brief introduction to interior and exterior angles of a polygon. Hope you have a good day.